So now we're going to talk about multiplying polynomials. This is again something that we've kind of seen before, but now we want to kind of bring it all together and really do a deep dive into what's going on when we're doing this. So multiplying polynomials really depends on the type of polynomial you're dealing with. Like this could just mean something like 5 times 3, right? And we just get 15, right? Like because two numbers are polynomials. So obviously that's not really interesting. Like we want to do something more complicated than that. What if we have 5x times 3x squared? Okay. So again, sometimes we might put parentheses around them to really distinguish which is which polynomial. So this is two monomials, right? A single term polynomials. So in this case here, all we need to do is use the commutative property of multiplication, right? We can do multiplication in any order. And technically we're using the associative property too to rearrange the terms, but so we get this, and then we can flip, right? This is 5 times x times 3 times x squared. So we can rearrange this as 5 times 3 times x squared. And then we have 15 times x to the third, right? So just using the commutative property of multiplication, using the rules of exponents, right? X times x squared is x to the third. That's just the definition of exponents again. So we will get 15x to the third. Now, when we start adding on terms, we have to be a little more careful. We essentially, whenever we're doing these, no matter how many terms we have in each one, we're basically just trying to make sure that every term in each polynomial is multiplied by every term in every other polynomial, or at least in the next polynomial. So like if we have two trinomials, then we want to make sure all three terms in the first trinomial is multiplied by all three terms in the second one. Okay, so we'll do lots of examples like this. So in this one, we just need to use the distributive property. Okay. So we're doing 5x times x plus 5x times 3. So we're going to get 5x squared plus 15x, and then we're done. Okay. Now if we have two binomials, then there's a couple different ways we can approach this one. So we can, again, use the distributive property. So in this case, we're going to take the entire x plus 3 term and multiply it by the first term on the x plus 5 and the second part of the x plus 5 as well. Okay, so we get x plus 3 times x plus 3 times 5. And then we can go ahead and do the distributive property again, because now we've boiled it down to the last case, right? Like 5x times x plus 3, that same kind of thing. And we can do this on both of them. So we get x squared plus 3x plus 5x plus 15. Okay. And now here we actually have a little bit of simplification to do because we can combine the middle terms, right? So we get x squared plus 8x plus 15. Now, the way that I prefer to think about these, or once we get more than one term in both of them, is I just like to kind of go through each term on each one and make sure it's being multiplied by every term in the other one. So the way that I would look at this is I would say, okay, I want to take x and multiply by x and by 5, and I want to take 3 and multiply by x and by 5. And that's just kind of a way that you could approach any of these problems. Just go term by term, and the first one, take the first term, multiply by everything, take the second term, multiply by everything. If there's a third term, multiply by everything, etc. Okay. Now with a binomial times a binomial specifically, a lot of people really like the FOIL method. It's really an acronym, which stands for first, outer, inner, last. Okay. A lot of people really like to think of it this way. A lot of people really don't like to think of it this way because it's a very specific case, right? It only works with a binomial times a binomial, which does come up pretty often, but you know, it's not anything special compared to other polynomial combinations. But regardless, it's just basically it's basically just a checklist to make sure that you've multiplied every term in the first one by every term in the second one. Okay. So if we go ahead and look at how we would do it with this, is it says, okay, multiply the first terms together, multiply the outer terms together, multiply the inner terms together, multiply the last terms together. So basically just how I was saying that I would approach it, right? It's the same idea here. So we have x squared plus 5x plus 3x plus 15, right? So again, we get the same thing. So it's basically, as opposed to the distributive property method, it's just basically skipping over this step here, right, where you distribute the first time. It's just skipping right from that first to the third step. So any of these methods are perfectly fine. I think I also like to kind of visualize what's happening here. So if we think about like a rectangle, like this kind of just informs us of exactly why this works. Okay. So if we have a rectangle where one side is x plus 3, one side is x plus 5, then their multiplying together would be, their product would be the area of this rectangle, right? Now we can divide this rectangle into different parts, right? So this side is x plus 5, this side is x plus 3. So let's divide this into an x by x square. First of all, x by x square. Then over here, obviously this isn't drawn to scale, as you can already see, but this is a 5 by x rectangle. This is a 3 by x rectangle, and this is a 3 by 5 rectangle, right? So we're saying this side is like x plus 3, so you know, the first part of it is x, and then you have 3 more units left over. This side is x plus 5, so same idea. So you break it up into each of these different combinations here, and then the area of each of these parts, this would be x squared, this rectangle would be 5x, this rectangle would be 3x, and this rectangle would be 15, which are the same as all of the parts that we had when we FOILed. So this is just kind of a nice visual of what's going on when we're doing this multiplication. It's like we're breaking it up into all of these different chunks and then just putting them all together, right? So it's like we're trying to find the area of this entire rectangle. So we do that by breaking it up into parts and adding those parts together. Okay, so just a visual representation of what we're doing algebraically here. So let's take a trinomial and multiply by a trinomial. X squared, let's say 2x squared, minus 5x plus 7 times maybe x cubed plus 15x minus 8. Okay. So you can go through the distributive property steps, or you can just go through term by term. So I would just say, okay, do 2x times first term, second term, third term. See what you get. Okay, so we get 2x to the fifth plus 30x to the third. We got to be really careful here because there's a lot of arithmetic going on that's where it's very easy to make mistakes. Minus 16x squared. I'll color code this. So then we take the second term and then multiply it by everything. Okay. So now we have minus 5x to the fourth minus 75x squared plus 40x. And then we take 7 and we do the same thing. Okay. So plus 7x cubed plus 105x, I want to say. 7 times negative 8 is negative 56. Okay. So ultimately now we just look for like terms here. And we do have a few. So it's it might be a good idea to like kind of cross the terms off as you go through them. Just to make sure you haven't missed any. So here I have a 30x cubed and a 7x cubed. So 37x cubed. Okay, I do have an x to the fourth term, which I missed. You don't necessarily have to write these in descending order, even though it is usually preferred. X squared terms, we have two of them, negative 75 and negative 16. So it's going to be negative 91 x squared. Okay. Plus 145x minus 56. So hopefully I didn't make any arithmetic errors. If I did, please have mercy on me. I won't be too picky about arithmetic errors either in my grading. So ultimately, though, this is what we get. We get this big long thing. We can't combine any other terms. There's no way to make this any simpler. So this is what we end up with. Okay. Again, if you want to visualize it, you could draw out a big rectangle and divide it into all of these chunks. So you would have essentially 9 different chunks, right? And each corresponding to one of the things I have written here, and you'd be adding them together. Okay. It doesn't make the most sense numerically because like we have negatives and stuff in there. But so it's just kind of like a quick visualization. It works better if you stick to positive numbers